Hey everyone, so today we're going to talk about increasing, decreasing, and continuity. So first of all, x and y, you guys know these, independent variable versus dependent. And we'll start using this function notation a little more often here. Y equals f of x, they're the same thing in a sense. F of x means a function with x as the independent variable. So f of x, a function of x. Okay, so you might have like h of t, like we did last, we talked about a little bit, like for height. So you could say height as a function of time. All right, so we'll talk about this a little bit more and get used to seeing that. And again, we say f of x, we don't say fx. All right, if you're asked to solve for it or rewrite it, you're gonna just solve for y. The first thing we wanna do is determine, so what this means, so f of 3. If typically it says f of x, only thing you're going to do here, so instead of wherever x is right here, x is right there. Now f of 3 would be 2 times 3 minus 4, or 2. So f of 3 is 2. And this just represents the point 3, 2, right? Like x value of 3, and the function value, or that dependent variable, the y value is 2. All right, g of negative 4, so we go to g of x. Wherever we see an x, we're replacing with negative 4. And we want to replace this with parentheses. I'll show you what I mean. So g of negative 4 is negative 2 times negative 4 squared plus 6 times negative 4 minus 10. So notice every time I plugged it in, I put those parentheses around it just to make sure. And I want to take care of negatives and such. So this would be positive 16 plus negative 24 minus 10. What do we got here? Negative 32 minus 24 minus 10 would give me negative 66. All right, so that would be g of negative 4 is negative 66. All right, and you might see some where it just says there's a different variable you're plugging in. So if we go back to our teal color here, we've got f of a plus 2. This one's a little strange. Would it be basically instead of f of a plus 2, or instead of f of x, f of a plus 2 instead of 2x minus 4, 2 times x, which is now a plus 2, minus 4. So again, it's replacing where x was in our original. So 2a plus 4 minus 4. F of a plus 2 is the same as 2a in the end. So if you have a different variable you're plugging in, you're probably going to end up with a variable in your final answer. All right, so that is function, evaluating functions, that's what we would call that. Something where it said evaluate f of 5 and you're given x's and y's. We're going to write this in function notation first, which means we're going to replace y with f of x. So the first thing we want to do here, this one's already solved for y. So this is the same thing as saying f of x is equal to 3x minus 4. So f of 5 is 3 times 5 minus 4, which is 11. All right, how about this one? Well, let's solve for x here. Negative 3y, solve for y, if I said that incorrectly there. Divide by negative 3. Y equals 2x minus 4. The reason we're solving for y, we want to replace that with f of x, 2x minus 4. Okay, and now we're going to find f of 5. 2 times 5, 10 minus 4 is 6. Okay, so that is all function notation stuff. We're going to keep using that and what it represents on a graph. Remember, this inside is the x value, and in general, f of x is equal to y, or our function value. So here's some important vocab words. Increasing, decreasing, constant. Okay, increasing, you're going to notice those are like the 3 things we're going to bring up about our graph that are new. Domain and range you've heard. Remember, domain is x values from left to right. Range is low to high. And increasing, decreasing, and constant. Okay, this is going to be, increasing is going to be when you have a positive slope of sorts. Decreasing is when you have a negative slope. And constant is when you have a 0 slope. Okay, so in a general sense, you're going to have some type of positive, negative, or 0 slope. The other thing I want to mention to you, and it says it right here, list the values of the domain. We always list intervals of x values. Okay, so we're going to list the x values that it's increasing, list the x values that this function is decreasing, and list the x values that it's constant. Continuous to us, okay, the easiest way to think of the word continuous is to think you don't have to lift your pencil. Okay, so if I had a graph like this, it's a cubic x cubed graph, I would not have to lift my pencil. Okay, if I had something like this, okay, there's a time when I had to lift my pencil to create the rest of the graph. These are called piecewise functions. And you could just have an open circle that's kind of stopping you from connecting your graph. So if you look ahead here, you'll see a disconnect. You'll see a disconnect here, a disconnect there. That is what discontinuous looks like. If we look at our first function here, as we drag our pencil along, that is continuous because it's traceable the whole time. We don't have any gaps. We don't have any splits in our graph, open circles, or undefined values. So first thing we're going to do is domain and range. So domain, how far left do we go? We go forever to the left, so negative infinity. How far right do we go? We go forever to the right, technically. So we cover all x values from negative infinity to infinity. For the range, you can think of it as like a little laser beam here. What's the lowest y value I have? Okay, it would be -4. Highest y value, infinity. Okay, so -4 included in our graph. So that's a bracket to infinity. Again, we're doing a bracket because -4 is on our graph. The only time we wouldn't if somehow this was an open circle, but technically a line is a set of all closed circles. Okay, increasing, decreasing, and constant. Here's what I want you to look for. Okay, increasing I'll do in blue here. You want to look at where is this graph generally positive? Positive slope. Remember, positive slope looks like this, right? Raises from left to right. So if I was looking at my graph, I would say from here to here, it has a positive slope. And in pink here, I'll do negative. From here to here, it's a decreasing, right? A negative line or negative slope of a line looks something like that, dropping from left to right. What are the x values this is happening on? Well, this, when are we decreasing? It's decreasing from negative infinity, right? At -100, right? -1000, this graph still has a negative slope. All the way up to x equals 2. Okay, we could do a parenthesis or a bracket. I'll talk more about that later. Let's do a parenthesis for now, that's safe. So from negative infinity to 2, okay, we have a decreasing slope. This graph, all the x values, and again, this is x values. When is it increasing? Well, it's increasing from 2 to infinity, okay? And again, a lot of people want to do this, -4 to infinity. I'm not looking at range, I'm looking at the x values. Okay, so starting at 2, going towards infinity, I would have a positive slope. That's what you want to think about, x values where I have a positive slope. The x values I have a positive slope are from 2 to infinity. Again, brackets and parentheses we'll talk about more. Let's just do parentheses for now, actually. Increasing, because I guess arguably, really it's not increasing or decreasing at x equals 2. And decreasing was negative infinity to 2. Okay, so again, notice these are x values. It's not constant anywhere. Constant would be a 0 slope. And we don't have any 0 slope here. Arguably, you could say at that point at 2, there's 0 slope, but there's not an interval. Okay, so again, we're looking for x intervals here. All right, now some new pieces you want to talk about. Find f of 4. Well, what does that mean? F of 4 means when x equals 4, right? This is f of x. So when x equals 4, what is y equal to? Of course, that looks like an x. Sorry about that. Okay, f of 4, we go to 4. We scan over here to x equals 4. What's our y value? It is 0. Okay, this represents the point 4, 0. How about f of 2? F of 2, if I scan over to 2, I drop down here. F of 2 would be -4. Okay, and again, this represents the point 2, -4. So how about when is f of x -4? Okay, I want to use kind of my little radar here, and I want to say when is y, right? This means when is y equal to -4. So if I scan up to where y is equal to -4, that's at x equals 2. Okay, and you could, like I could say something like when is it equal to 6, and you would actually have 2 values. Okay, so that is possible. Other thing I want to say is, sorry, this was x equals 2. Where is it discontinuous? Nowhere. It is continuous throughout. Remember, continuous means we don't have to pick up our pencil. All right, let's try a little bit tougher one. Take a look at this one. These are called piecewise functions because they're pieces of a graph put together. All right, so let's think about domain and range. Okay, how far left does this graph go? So I'm going to use my little laser beam here. Okay, if I'm scanning to the left, how far left do we go? Well, it's going to go actually forever, right? Because that arrow is pointing us left forever. So from negative infinity. Okay, once we get here, let's think about where x is defined. Are we defined here? Yes. Is it hitting something? Yes. Now, when we get here, okay, do we have a defined x value? The answer is yes, and that defined x value is going to be right here, the closed circle. The open circle represents that the graph goes really close to 0 but does not actually have a value there. So I just want you to be careful. Yes, the domain exists, or the domain is defined, okay, and we can continue. So you want to look for any gaps this laser beam would shoot right through and not hit any piece of the graph. So right now it's still hitting. Yep, it's hitting something, yes, yep, good. Oop, now it's shooting right through our graph. So that means the domain only goes up to 8, okay. How about range? Flip this line around. Okay, let's see what we got. So we're scanning what's our lowest value. Well, it gets really close to -6. We have an open circle there, so we're going to do -6 with a parenthesis. And we're going to start scanning. Are we hitting a value here? Yeah, see over there on the left, we're hitting a value. Yes, still hitting a value, still hitting value, still. Are we hitting a value here? We are. Look at this arrow, guys. That arrow is going to go forever. So technically, we have y values defined up to infinity because this guy is going to continue forever hitting that line. Now, domain and range are tough. I don't want you guys to sit there. If you're very confused about that, maybe rewind a second and watch that again. But those are tough topics, so don't be afraid to ask questions about those as we go. Increasing, decreasing, and constant. Let's do those same colors here. So increasing, I think I did blue. Okay. You want to look for anywhere with a positive slope. All right, positive slope looks like that. So I'm seeing this area increasing, and I think that's all I see. How about pink? We'll do decreasing again. So where is there a negative slope? Well, how about right here? We have a negative slope. And fun fact, in this one, we actually have a 0 slope or constant. Once we have those things highlighted, again, we're using x values here, or x intervals. So don't look at the y values, just look at the x values, and we're thinking where on the x-axis are these things increasing, decreasing, or constant. Let me highlight match here so you guys know what I'm talking about. Okay, so where was this blue? Where were we increasing? From x equals 4 to 8. You can also put brackets, it doesn't matter. Increasing, decreasing, and constant, I'm pretty flexible about brackets versus parentheses, and again, we'll talk about that more. Constant, that would be from the x values of 0 to 4. Again, what x values? From 0 to 4, I had a constant slope, or that 0 slope. Where was I decreasing? I was decreasing, well, all the way from negative infinity up to the x value of 0. So a lot of people want to say -6. We went from negative infinity to the x value of 0. That's where we were decreasing. So again, we're always looking at those x values to choose. And let's try some of these out. Okay, these ones below, we'll finish up with this. F of -4. Okay, so where is -4? So we're looking at when x is -4, what's y? That would be at -2. Again, this represents the point -4, -2. How about f of 0? Now this is kind of a weird one I already talked about. At x equals 0, if I drop down, you'll notice I have 2 points here, but only one of them is a filled circle. That is where this is defined. You might be wondering, what if both of them were filled circles? This would not be a function then. It would not be a function because it would actually fail the vertical line test. How about f of 8? I go over to 8, I kind of scan up and down, I'm at y equals 0. F of 12 is way over here, it's not even in our domain, so no solution, or there's no value at 12 that we know of. Okay, where is this continuous? Where are we continuous? Well, I'm continuous. Where do you have to not lift up your pencil? If I start over here, I'll start with, we'll use a different color. I'll use like a green highlighter. So I'm continuous from negative infinity up to 0. Oh, Now I have to pick up my pencil. So at 0, I picked up my pencil. I'm still drawing, still drawing, still drawing. And at 8, I end. So it's continuous from negative infinity to 0, union 0 to 8. That is where I'm continuous. Again, I'm continuous. And I said 0 was a parenthesis because I don't want to say I'm continuous at 0, even though there's a closed circle. I want to say I had to skip over 0. That's not where I was continuous. It's discontinuous. You could also write it this way. Discontinuous at x equals 0, this graph. Okay, where is f of x equal to 0? Last one here, guys. This means where's y equal to 0? So take a second if you want to erase anything. Okay, you're going to take this pink line here, personally. I'm going to scan when y is 0, so I'm going to scan up to where y is 0. That's right here. When y is 0, what's x? Well, it's -6, and where else does it intersect? 8. So x equals -6 and 8. All right, those are the two values where I get a y value of 0. All right, guys, and that's it. So take a second again. These are not easy, but definitely something we have to feel comfortable with that will follow us through all the way till calculus. So please let me know if you have any questions at the end of this video, and bring in any other thoughts to class. Thanks for watching.